Note 6, more with rational exponents. So we're going to review the laws of exponents. If we have like bases, we add the exponents. We keep the base and add the exponents. So 3 to the 15th power times 3 to the 4th power is equal to 3 to the 19th power. Quotient, when we are dividing, we subtract the exponents. So this is x to the m minus n. When like bases are divided, keep the base and subtract the exponents. We have like bases here, 4 to the 9th over 4 squared, 4 to the 9 minus 2, which is 4 to the 7th power. Anytime we have power to a power, pay particular attention to the power on the inside and multiply it by the power on the outside. Power to a power. So when something to a power is raised to a power, just multiply the exponents. So 5 to the 8th raised to the 3rd is 5 raised to the 8 times 3, which is 5 to the 24. So power of a product means multiply. We're going to raise each individual term to the m power. So this is x to the m, y to the m. So if a product is raised to a power, multiply the inside exponents by the outside exponents. Power of a quotient, x over y raised to the m power. Treat a quotient raised to a power in the same manner as a product raised to a power. So 7, we're going to raise 7 to the 5th power over 3 to the 5th power. Negative exponents. Anytime we have a negative exponent, we're going to write it as a reciprocal. So this is 1 over x to the m. So anything raised to a negative power belongs in the other half of the fraction. So 5 to the negative 8 power is 1 over 5 to the 8th power. So let's practice. Do we have like bases? And the answer is yes. So we're going to keep the base and add the exponents. 1/2 plus 1/3. Put it in your calculator, 1/2 plus 1/3. You'll get a decimal, hit math, enter, and you'll get 5 over 6. So 6 raised to the 5 over 6. 27 raised to the 1/2 power times 3 raised to the negative 1/4 power. What do you notice? We notice that the bases are not alike. So at this time, we can actually make them alike. 27 we can rewrite as 3 to the 3rd power. Raise it to the 1/2 power and multiply times 3 raised to the negative 1/2 power. Guess what? We have like bases and we can add the exponents. If you don't like the way this looks, I can rewrite it as 3 to the 3 over 2 power plus, and then we'll put negative 4 in parentheses, negative 1 over 4. Because some students are like, well, it's subtraction and we're not dividing. Well, we're adding a negative number to a positive number. So that gives us 6 over 4 minus 1 over 4, which is 3 raised to the 5 over 4. So changing those bases help. 8 to the 1/3 times 2 to the 1/4, all raised to the 2nd power. If possible, rewrite the base as a prime, or at least a smaller number. So 8, we change to 2 raised to the 3rd power. And this time we're going to multiply the powers. 3 times 1/3, which gives us 1. Let's multiply the other powers. 1/4 times 2. See what we get. Yep, we get 1/2. So now we have like bases and no parentheses. So we have 2 raised to the 2 plus 1/2 power. So this becomes 2 to the 4 over 2 plus 1 over 2, which is 5 over 2. Let's try this one. This time I'm going to do it a little different. I'm going to multiply the inside exponents by the outside exponents. So I'm going to multiply the inside exponents times the outside. So that gives me negative 1 here. I'm going to do it with the other power. 3 times negative 1/3 gives me negative 1. So now they have negative exponents. They belong in the other half of the problem. So I'm going to put them in the denominator. I get 1 over 4 times 2, which is 1 over 8. So here we're going to rewrite in simplest radical form. So we're going to rewrite this as a radical. So if you notice, the 2 is raised to the first power, so it's not a rational, so it's not even going to be under the radical. And everything else is under the radical, x to the first and y to the second. So we rewrote this as simplest radical form. Well, let's take a look at our next example. We have different variables and we have different fractions. So what we need to do is find a common denominator. 1/2 is the same as 3 over 6, and 1/3 is the same as 2 over 6. So this gives us the 6th root. Here's the root. And the powers go with the variables on the inside. M to the 3rd power and n squared. Here, let's take a look. Power to a power. On the inside, these two have a power of 1. So if I multiply that times 1/3, I have 5 to the 1/3, x to the 1/3, and y to the 3/4. Go ahead and get a common denominator and get ready to write it as one radical, all to the 12th root. So here we go. Here's my 12th root. Powers stay with the numbers. 5 to the 4th, x to the 4th, y to the 9. If I multiply 5 times 5 times 5 times 5, I get 625. Next, notice 3 is to the first power, t is to a whole number, the 3rd power, so will they be under the radical? No, they're outside the radical. Only the ones with rational exponents go under the radical.